come up one at a time, and you can, if you got the question right, you can show everyone how to do it. So off you go, Emma.
No.
No, it doesn't have to be perfect, remember, sweetheart.
So if y is 4, x is 2, then we would substitute 2 is where the x is. So 2 is 2. Then it would be minus 6. Bracket 2 squared plus 20. Then we just simplify that to 8 minus 24 plus 20.
Great. Oh, I thought you were doing the whole question.
I am? Oh, yeah, I'm sure. I like writing those hard words.
So how do you feel that, how did you complete that?
So you would substitute negative,
Oh, sorry, you want...
So you'd substitute negative 1 into this equation up here. So it would be negative 1.
Thank you. Sorry, can I just say one thing how you've written that? Whilst I love the fact that you're using brackets, unfortunately, if you type that into your calculator just like that, it would tell you the wrong answer. Can anyone tell me why it would tell you the wrong answer? Casey? Yeah. Okay, you all happy with that? Oh, no. Oh, no, I think it's going to close it. Let's just try and keep going. Okay, and then what would you do? Bless you. As coordinates, yeah. Okay, you're happy with that? When you do it, it kind of looks like this. Oh, it really doesn't. It really doesn't. It really, really doesn't. But when you plot them, you'll see that it does that. Now, a couple of people didn't plot, or unfortunately, the way the mark scheme works is if you didn't get this mark, you couldn't get this one, even if you plotted your values, which it seems harsh, and I agree, it seems harsh. However, I'm marking with the mark scheme, so that's what's going to happen in real life. It's at these kinds of stages that when you look at this graph here, because the power of x is a 3, I want you to try and recognize what it should look like. So it should either be doing that or that, ideally, okay? So if your coordinates somehow don't follow that pattern, that's when you need to double check them, okay? Right, next question. Hang on. Yeah.
Yeah, so you put F and G.
Okay, so just note here, Mia's put it in both positions for x. So if there's an x in two different places, you have to replace it in both of those positions, okay?
And we simplify that and you can simplify that again.
Okay, that's awesome. Thank you, Mia. Perhaps I can help a little bit in addition to that. So whilst Mia expanded it completely correctly here, in hindsight, it could be easier not to expand it and to actually keep it as 2x squared plus 1. Sorry, it's really hard with the mouse. And then you've got 2x squared on the bottom. Okay, so we've simplified the bottom here. And then hopefully you can see, because these two are multiplied together and these are multiplied together, it means that we're allowed to cross things out. Okay, so remember, you cannot cancel things out unless they are being multiplied by something else. In other words, it will involve you factorizing. Okay, so because we're able to do that, that's when it simplifies to be the 2x squared plus 1 on the top and then x squared on the bottom. Okay? All right, so we're doing the inverse of g, so g minus 1 is different than the inverse, so 2x of x. All right, so this is what I'm finding the inverse of. What's the rule? What do we have to do to, what's the first step? Lily, get rid of the trainer. And what do we do?
You write y equals...
Wait. Gabrielle, what do we do then when we're finding inverse functions? No recollection whatsoever. Someone else in the room, other than DNA, must remember what do we do. I'm not asking you should necessarily do it, but what do we do when we're finding inverses? Shayla? Yeah, switch it x and y. So anywhere that you did see a y, you're going to write x. Anywhere you did see an x, you're now going to write y. Okay, so you're going to write x equals 2y over y minus 1. So that is our procedure. So when you're finding inverse functions, write y equals and then switch your letters. Because remember, that's what an inverse function is. It's where your x, your domain has become your range has become your domain, and it's a reflection of the line y equals x. Alright, what do we do now? We need to make y the subject. So I've got y in two different positions here, so it's your rearranging skills that come into play here. I'm going to remove my denominator here, so I'm going to multiply both sides by y minus 1. So I'm going to have an x bracket y minus 1 equals 2y. Apologies for going back over here. I'm now going to expand my brackets. But I have y in two different positions. This is stuff that we were learning last year. What do I do now to be able to get y on its own or to isolate y? Not yet. Because I've got y over here and over here. What do I have to do? When we do any kind of solving,
Get rid of that.
rearrange it. Yeah, we need to have our y's together, don't we? Alright, in a moment they're on different sides of the equal sign. So, I'm going to subtract 2y from both sides. And I'm going to add x to both sides at the same time. Are you all happy with that? Okay, so I've just rearranged this, so I've collected my y's to be on the same side, and I moved my x, my isolated x, to be on the other side of the equal sign. So but I still have y in two different terms, so what can I do now that they're on the same side? Yeah?
X minus y plus 1. Oh no, x minus 2 plus 4.
Yep, what's that called? Factorizing it, because I have y that's common. So y can come to the front, and I have x minus 2. What's my final step? Everyone should be able to know what my final step is. Divide by x minus 2. So I've got x over x minus 2. Okay? So that is one of the challenging rearrangings. But I'm hoping that you can see how it's at this point things will start to come together. So whilst this is a function inverse question, it's one of the more challenging ones, and it brings in stuff that we learned last year. Can anybody signify what you're talking about? And one of you move.
Oh, I was just asking if the highlighter.
So you're still involved. So one of you move.
It's not.
Okay.
We have to substitute the 1 over 2 into the x, so that it would be x and then that would be 12. And that would equal r over 5 over 0.
Lovely, thank you.
Okay, so it says to find f of the x. So since the, can I scroll down?
Yep.
since the g is closest to the x, then we do the g first. So gx equals the square root of x minus 1. And then you substitute that into the equation for fx. So you get 1 over square root of x minus 1 squared plus 1. And then the square root and the square cancel out. So then you're left with 1.
Do you want to? You can extend it. Can you?
Okay. So you're left with 1 over x minus 1 plus 1, and then these two cancel out. So you're left with 1 over x.
Lovely. Thank you. Okay. Off you go then.
It's the inverse form of fx, which is 3x minus 2.
Yep.
So it basically wrote that. And then I was like, what's the opposite of each? So I just wrote 1 over 3x plus 1 half, because that's like the opposite of
Okay.
that.
No. So whilst that's fine, what about the method that we just talked about? What did we say? No,
Could you try it with the method, but that's not what I...
No, absolutely, darling, and that's fine. It's just that I'm concerned that that's not going to help you for other questions. So try the method that I just went through. So what did we say to do?
You make it y equals...
Go on then.
y equals...
Yep.
And you switch to...
Mm-hmm.
No.
Yeah?
Yeah, okay. So...
Bless you. This should be a nice rearrangement.
So then you're going to bring your 2 over, that's x plus 2 equals 3y.
Mm-hmm.
And then you want to get rid of your 3, so y is on its own. So then it's x plus 2 divided by 3 equals 1. So that's your answer.
Yep, perfect. Lovely. Thank you very much. Okay, off you go. So which one's going into which?
So the F is going to go into the G.
Yep.
So any time you see X, we're going to put G. I mean, yeah. That's what happens. And that flies through.
Perfect. Thank you. Girls, all right. Now, as I said, there was some horrible maths going on in these, mainly because I don't know how else to remind you. Or could you put? Have you got a pen? You just put 1 second. I don't know how else to remind you that if you have an x squared here and an x squared here, you cannot do that. Okay? I saw that happening, and I just want to cry and hunt you down. So please do not do that. Okay? What has to happen in order for you to cross stuff out?
It's multiplied.
Has to be multiplied. So which process is going to be involved? Factorizing. Okay, so you have to look at these expressions and think factorize. Not, oh look, there's some x's I can cross out. Because Miss Harrison will hunt you down. Okay, go Mia.
So what you want to do is you want to take okay, so you factorize it here. I don't know if it's called factorizing.
Yes, we've just discussed that.
So you do that. So you got that. And then you want to make this be a bracket on the bottom so you can cancel it out. So you want to make this so that you can then factorize it into a bracket right here. you can do, I think, plus xx minus x minus 3. Is that what
Yeah, so this is a splitting difference term.
Because that equals 5x, but you just want to, this is important because then that can simplify to make that somehow. So then from there, you can keep the 12 the same. And then you do, right, because you see it, that's 2. Stop laughing at me.
Girls, don't laugh. She's doing it right. So just remember Neopats. We normally show a line between the plus 6x and the minus x.
Where?
So on the other one, yeah, just draw a vertical line. Remember, we cut it in 2 halves, and then we factorize each half separately.
Yeah. Yeah, no, because these two, right, equal 5x.
Oh, okay.
It's just
so much sense.
Yeah, I'm sorry if that wasn't clear.
Thanks. Yeah.
And then from here, see, so you see how that equals that, right? And then you do, like, I'm running out of space. -1. This is a -1. And then you do x plus 3.
Wait, is that an equal sign?
No, that's a -1.
Sorry. And you can see, because our whole point of doing that was to get an x plus 3 in both of these, so you can take it out, you know?
Okay.
You can go like that, and it'll be 2x minus 1. Right. You'll factor in the quadratic thing, right?
Does that say -1 bracket?
Yes, it does.
Yeah, sorry, it's awful. And then you can just do that. And then, I don't know if you said point 1 after that, there you go. And then, I'm going to write some color. Okay. I got space. X. And then it's the x over 2x minus 1. Right? So we should do that's one big.
Lovely. Thank you. Brianna has a question for you, Mia.
Okay. Yeah, Brianna?
Where is the other x plus 3 go?
Oh, well, see, with this method, when you have 2x, it's the quadratic method, so you just put it together.
She's factorized it.
Yeah.
Yeah, so like there are 2. There's 2 x plus 3.
Mhm.
But because they're both in this form, you can simplify it like that.
So basically, one is being multiplied by 2x, and one is being multiplied.
Okay, hang on. Go. Go. Just press extend page, sweetheart.
Down at the bottom. Right there. Okay, so you gotta make it so that y equals x plus 2x minus 1, right? And then you change that so it's x equals y and 2y minus 1 if you do it in first fractions. And then from there, you x and you multiply it by xy minus x equals y, right?
Yeah, but does everyone know happy where you got the 2xy minus x
Yeah,
from?
so you can put it in brackets. It would be x brackets 2y minus 1 and you simplify that to get that.
Perhaps write it in the middle step. Just write it up above it. 2. That's it.
I don't know why I wrote it like that, but you get it, right?
Yeah. Thank you.
Yeah. Okay. So you got that, and then from there you have to take the y here. So it'd be where would you put the y?
So you're going to put the y's on the same side as each other.
So 2xy minus y equals x.
Mhm.
And then from there you can factorize.
That's right. Excellent. You're even using the right words.
Change your color. 2x minus 1 y x, and then put that divide into
Lovely. Thank you.